Hi, and welcome to another video of Chem with Com. Today we're going to do the third part of Lewis structures, bonding, and molecules, specifically molecules, compounds, and chemical formulas. All right, so now that we are starting to build molecules, right? We started with atoms and we're building up to molecules. We have to know kind of how to call things, what things are, how to classify things, right? So this is where we're going to start. Um, Chemical formulas. We've been seeing these. This is a typical chemical formula here, CH4. This is methane. This is carbon attached to four hydrogens. So one, and there's a carbon, there's four hydrogens. That's what that four means, right? Those four hydrogens are connected to that carbon somehow, and through Lewis structures, we figured out those are covalent bonds, right? Each of those lines represents two dots. This is the ball and stick model. This is a space filling model, right? Just kind of how big the radii of the I guess the electrons and atoms will be. All right. So, and then this four directly is tells you that there's four hydrogens. This has nothing to do with how many carbons there are, right? This is that four is specifically for that hydrogen. So there's one carbon, four hydrogens. All right. So all of these are elements of the same thing. They're all hydrogen, but they're arranged differently, right? This is a single hydrogen atom, so it can be either written as hydrogen or one hydrogen. These are two separate hydrogen atoms. They're not separate, right? Separated. So we say there are two hydrogen atoms. This two applies to everything after. This is just a single H, so that means there's two hydrogen atoms. H2, that subscript means they're bonded together, right? And that's a single molecule. So it's one H2 molecule. Here, there's two H2 molecules. Again, this two applies to everything here. So because the two's on the left side, and it tells us there's two H2 molecules, right? There's one H2 molecule and there's a second. So these are individual atoms, right? We see the atom here, we see those two atoms. Once you start combining atoms together, they're called molecules. So more than one atom is a molecule. This is a molecule, this is a molecule, this is a molecule. These are a pair of molecules, right? All right, let's go a little further. So, like we said earlier, right? There's these hydrogen molecule. That's a molecule. That's a molecule. That's a molecule. This would be written as three H2 molecules. This is an O2 molecule, O2 molecule, O2 molecule. This would be written as three O2 molecules. This is one molecule of phosphorus. Molecule. A single atom of phosphorus would just be that, right? That would be 1p. This one, since there's four of them, and the subscript here, that applies to that. There's four phosphorus atoms combined together to make a phosphorus atom, right? That would now be one single P4. The sulfur is much more complex. This is just a single sulfur molecule, 1s8. All right. So again, all these, everything on this page now are all molecules because they're more than one atom. And these are all the same, right? The same atom. multiple of the same atom bonded together. Now, we're going to talk about compounds, which are two or more different atoms, right? They're all molecules, but compounds are two or more different atoms. Here, water has a hydrogen, and let me get a different color because you can't see that. So hydrogen, this is an oxygen and a hydrogen. Hydrogen, sorry, oxygen is the white one. I got a little fast there. All right, this is hydrogen, oxygen, hydrogen, hydrogen, oxygen, hydrogen. There's three of them, so this would be listed as 3H2O molecules. All right, this is an oxygen, carbon, oxygen. So this is CO2. There's a single CO2 compound, right? This is three H2O compounds. Glucose is a very complicated compound, and there are one of those, right? There's 6 carbons, 12 hydrogens, and 6 oxygens, all bonded together in one molecule or one compound, but that's glucose. All right, so when we talk about molecules and compounds and atoms, we have to know what we're talking about, and this is where we're going to get our information from. All right, so what are things called? Atoms, elements. This is what we just kind of covered. And I'm going to underline some stuff where you can see the similarities, right? Molecules, more than one atom. Molecule, molecular, right? Multiple of the same atom. All right. We have molecular compounds, two or more different non-metals. Non-metals because they are covalently bonded. All right. So then we have compounds, right? I'll do it in a different color. Oops, sorry. Let me actually, I want to underline the stuff that's the same because you can use it over in different things, right? Ionic means metal, non-metal. Compounds mean two different, um, let me get a green one going here, right? Compounds, two or more different atoms. Well, molecular compound, two or more different non-metals. Ionic compound, right? Metal and a non-metal. All right, so let's go through this list and figure out what's what. Helium, if it's the straight up element, that's going to be atom or element. I think typically for this, we're going to stick with this. It's more descriptive, I believe. Not by much, but a little bit. And so let's go down the list. NO, two different atoms or two different elements, right? And they're non-metals. So this is going to be a molecular compound. H2O, right? It's multiple, it's a molecule because it's more than one atom, but it's two different, and those are both non-metals. So that's going to also be a molecular compound. Fe, that's just a straight up element. H2, right? That's a molecule, but specifically, it's multiple of the same atom. So it's going to be called a molecular element. NaCl, this is the metal. Two different ones. So this is going to be a ionic compound. All right. Let's continue. Before I forget, the secret word of the day is sassy. Sassy. The word of the day is sassy. All right, let's look at these chemical formulas now. And we've been talking about these, but just to show what we're talking about, right? Subscript numbers small into the bottom right, something like O2 is just for what is immediately to the left of it, right? If there are parentheses, it's the number of things in the parentheses. And I'll show you that here. The number on the left of the molecule is the coefficient. I know I'm trying not to use a ton of vocabulary, but this is something you can't avoid. And it tells you how many total molecules, I guess, or atoms there are, right? So H would be just a single hydrogen atom. So I'm just going to draw an H there. H2 are two atoms, but since it's subscript, it's going to be bonded together. And there's one of them, right? So one H2, H2O, it's one molecule. It'll all be bonded together. So H, O, and H. Since there's no coefficient, it's always going to be one. If there's no coefficient, it's one, right? But we leave it off a lot of the times. All right, let's check this out now. H2O2, it's going to look something like this. So since they're all connected, right? There's no spaces between them, and there's two H's, two oxygens. You probably don't know how to draw this yet, but I'm just gonna, this is more of a descriptive thing of how we're gonna identify things with chemical formulas. All right, that's gonna be an oxygen. This will probably be another oxygen. This will probably be a hydrogen, something like that. And there's only one of them, right? One H2O2 molecule. Now we have a two here, right? It's going to look like this. Like I said, I don't know exactly sure how this looks, but I think it looks something like this. But there are two of them, so we have to draw two complete ones. And again, we're just classifying things here. You don't have to draw these. I'm just drawing them so you have some kind of visual, but there's one and then two of them because of that two. That two again applies to everything. All right. Now, these are what are called, this is an ionic compound, not necessarily, there's no metal here, but these are two what are called polyatomic ions, and they're held together because this is a positive charge, this is a negative charge. So they come together for an ionic bond. All right, so now I'm going to attempt to draw this out, but it looks something like this. All right, so it's going to be a NH4. You might not know this yet, but these are going to be 1 plus. You have a SO4 2 minus. Um, and if you look here, there's a 2 right to the left of these parentheses, right? So that means there's 2 of whatever is in those parentheses. So that means we have another NH4 1 plus. All right, and there's nothing there, right? So we're not going to have it, but we have two of these complete molecules, so two of everything. So that means we have this, right? So we have one and we have two of them. So two NH, this is called ammonium sulfate. We have two molecules of ammonium sulfate, or 2 units of ammonium sulfate. All right. So we also have something called empirical formulas. Now, empirical formulas are molecular versus empirical. Molecular are all atoms in molecule. Empirical formula is same ratio of atoms, but lowest subscripts. right? Um, so vinegar from molecular, it's going to have a formula of C2H4O2, where the empirical, right? Again, all atoms in the molecule, and this one is the same ratio of atoms, but the lowest subscripts. So this, if we reduce these subscripts to the lowest numbers possible, that's going to be a C1H2O1. And we would write it as CH2O. Now, if we were to assemble a molecule that's CH2O, that will not be vinegar, but it has the same ratio. So molecular formula and empirical formula are different. But a molecular, again, are all the atoms in the molecule. Empirical are the same ratio of atoms, but lowest subscripts. All right, let's try a couple of these. Let's do something like molecular formula N2H4. Empirical formula would be NH2. All right, let's do something like H2O2. Empirical formula would be HO. All right, let's do something like C3. Oh, no, let's do C. I'm just making stuff up. These might not even be real. C4H12. Let's do 14. Maybe that is C2H7, right? Because you divide the 4 by 2, you divide the 14 by 2, you get C2H7. All right, let's do another one. C5H12, right? Now the empirical formula is actually exactly the same because you can't get any lower than that without getting decimals. Let's do H2O, right? We can't. Same thing. All right, let's do something that we might be able to do. Let's do C6H12O6. That would be CH2O. Right? So again, molecular formula are all the atoms involved. Empirical formula, the same ratio of atoms, but the lowest subscripts. All right. Let's try this. A molecule of metaldehyde contains 8 carbon atoms, 16 hydrogen atoms, and 4 oxygen atoms. What is the molecular empirical formulas of metaldehyde? So carbon, they say we have 8 of them. So this is the molecular, and this is the empirical. C8H16O4. Empirical, so we divide everything by 4, that becomes C2H4O. All right. And you have other formulas that are the same that are arranged different, right? Acetic acid, which is the same thing, vinegar, C2H4O2, and methyl formate. C2H4O2. They're different things, right? Vinegar tastes good in some sauces and some soups. Methylformate is probably toxic. Not sure, but it probably is. All that is the carbon and oxygen look like they're mixed up or a little different rearrangement, right? But you can see that's not the same chemical and it probably has different properties, right? And these are called isomers, right? Isomers have the same formula, but arranged different, therefore different chemical properties. All right, so now let's figure out how to calculate the grams per mole for these different atoms or elements or molecules. Hydrogen, you look on the periodic table, boom, there's a single one, 1.008 grams per mole. I like writing it this way, grams per mole. All right. H2, there's two of them. So if I have 1.008 grams per mole, sorry, let me just write it the way I like to. It makes it a little easier, or easier for me, I guess. Grams per 1 mole times 2, that's going to be 2.016 grams per 1 mole. All right, I'm going to take this one out a little further just so we can see this. All right, H2O means we have one hydrogen. We have two of them. Each hydrogen is 1.008 grams per mole. We have oxygen. We only have one of those times 16.00 grams per mole. This is going to be 2.016 grams per mole. This is just 16.00 grams per mole. We add those together and we have 18.016 grams per mole. All right, so now let's do two waters, right? If we have two waters, how many hydrogens do we actually have? Well, two hydrogens times two is going to be 4 grams per mole. For oxygen, we have now, instead of 1, we're going to have 2. So this is going to be 32.00 grams per mole. Here we're going to have, let's see, 4.032 grams per mole. We're going to add those together. Again, always bring your calculator. This looks like it's going to be 36.032 grams per mole. So you just add all the atoms up basically, right? 4 hydrogens, 2 oxygens. This one's two hydrogens, 1 oxygen. This is just 2 hydrogens. Here is just 1 hydrogen. All right. So we know how to get these off the periodic table. We have to know how much, sorry, oxygen's right here. And again, we're using the grams per mole. So let's use this column. Even though they're the same number, let's just stay focused on the molar mass. All right. Grams per mole of these different molecules. So let's try this. Acetic acid, right? There's going to be carbon. There are two of them, and it's going to be 12.01 here, grams per mole. We have hydrogen times 4 times 1.008 grams per mole. And we have oxygen times 2, 16.00 grams per mole. Let's do the math here. This is 24.02 grams per mole. This is 4.032 grams per mole. And this is 16.00 grams per mole. Oh, sorry, 32. Sorry. Add these up. It's going to be 4, 10, 3, 4, 5, 6.052 grams per mole. But again, we have to do sig figs, right? So this is our answer for now, but we have to do sig figs. I'm going to do this in blue. Here there are two decimal places. Here there are three decimal places. Here there are two decimal places. So we have to use two decimal places in our answer. So that's going to be 60.05. Now, if we are going to use this to carry on and do other calculations, so for further calculations, do not round yet, right? We're going to write that down. Again, this is grams per mole. We're going to say 60.052 with the overline. That tells us, hey, that's the last number that's significant. So we're going to use that in our continued calculations if we have to. If you don't, stop there and then you're done. All right. So we're going to calculate the grams per mole and the empirical formula and molecular formula. All right. So let's do this here. We said the molecular formula was C8 H16O4, right? There's going to be carbon times 8 times 12.01 grams per mole. Hydrogen times 16 times 1.008 grams per mole. Oxygen times 4 times 16 grams per mole. Let's do the math. 8 times 12.01. I have 96.08 grams per mole. 16 times 1.008. I got 16.128 grams per mole. And I have 4 times 16, which is 64 grams per mole. We're going to add those up and it becomes 96.08 plus 16.128 plus 64. I have 176.208 grams per mole. But with rounding, we want two decimal places because here there's two, so it has to be 176.21 grams per mole. And we're not using this for any further calculations, so we're going to stop there. Oops, sorry, let me not put that two decimal places in the answer. Let me just do this. All right, this is the molecular, and let's do the empirical. All right, so that becomes C2H4O. So we have carbon, we have two, each of those is 12.01 grams per mole. We have hydrogen, there's four of them, 1.008 grams per mole. Oxygen times one, that's only 16 grams per mole. Let's do the math. 24.02 grams per mole. 4.032 grams per mole. 16 grams per mole. Again, calculator, you want to do every single calculation that I do because it's free practice. It helps you with your calculator and you're going to get faster at it so that you're ready to blaze through those exams, right? All right, so we need two decimal places because there's two decimal places here. So it's going to be 44.05 grams per mole. But again, if you're using this for future calculations, don't round yet. Round after you're done with all the calculations. All right, well, thank you very much. And that was it. And I will catch you next time. Have a good day.